All right, you have reached the video on expressing scientific notation in binary. This video assumes that you've seen my other videos on expressing numbers in binary. So if you haven't checked those out yet, I recommend you watch those first. How to express scientific notation for floating point numbers in binary. We'll do an 8-bit example to keep this simple. Just remember that a 32-bit or single precision or 64-bit double precision works similarly, but more bits allow for a larger range and higher precision. Read up on standard methods like IEEE 754 to see how this is done in practice, as some things are a little different. We'll use the leftmost bit to store the sign, 0 for positive, 1 for negative. We'll use the next 3 bits to store the exponent as a binary integer, where 3 bits gives us a minimum of 0 and a maximum of 7. But let's apply a bias of 4. So if we subtract 4 from our range, now it goes from -4 to +3, allowing both negative and positive exponents. Next, we'll give up our exponent of -4, changing our range from -3 to +3, and we're going to let the binary value 0, 0, 0 indicate that the entire number is 0, and you'll see why. Finally, we'll use the last 4 bits to store the fraction. Now here is where we gain an extra bit, since scientific notation assumes a non-zero digit to the left of the point, and of course in binary all you have is 0 and 1, so if it's not a 0 to the left, it has to be a 1. So this, combined with the fact that we have reserved the exponent 0, 0, 0 to indicate that our entire number is 0, we come out ahead by getting a 5th bit for free in the fraction. Thus, our fraction can be represented like this, where notice I have made the 1 to the left of the point bold, as that value is always 1. Thus, our 4 explicit bits for the fraction are increasing negative powers of 2. Let's do an example using the binary value 10, 10, 10, 10. Our sign is of course negative, and our fraction written in base 2 or binary is 1.101, and our exponent is shown as 2 to the binary number 10 base 2. Notice 2 things about the exponent. One is that we're multiplying by a power of 2, not a power of 10 as we see in our standard base 10 scientific notation. Also, again, notice that the exponent is written in base 2. Next, let's write our fraction expanded as a sum of decimal values. We simplify that, and now let's take a look at our exponent, where the number 10 base 2 is simply 2. But don't forget, we need to subtract the bias from that exponent, which makes our exponent actually a -2. Simplifying further, we have our answer. It's -0.40625. And of course, that number is in base 10. All right, folks. I'm Dr. G. Thanks for watching, and I'll see you in the next video.